5, 4, 3, 2, 1.
Ice absorbs heat from metal faster than it absorbs it from wood. Wood is an insulator. It slows down the transfer of heat to the ice. Metal is a conductor. It absorbs heat readily and passes it on quickly. Water is a very fickle material. The introduction of a contaminant will instantaneously drop the freezing point below 32 degrees. It's true when you added the salt, you introduced a contaminant to the frozen water of the ice. The ice then melted and froze around the string as the contaminated H2O molecules were cooled by the surrounding molecules. This small amount of water cannot exert much pressure on the inside walls of the can. So, the pressure of the air pushing from the outside of the can is great enough to crush it. By now, you've probably guessed that the money will actually burn if you dip it into a pure alcohol solution. The secret, of course, is the addition of water to the mixture. The water from the water-alcohol mixture absorbs much of the heat energy that is generated when you ignite the bills. The temperature of the paper money does not rise above the temperature required to burn the paper. Warm water is lighter in weight or less dense than cold water. When the bottle of warm water is placed on top of the cold water, the more dense cold water stays in the bottom bottle, and the less dense warm water is confined to the top bottle. However, when the cold water bottle rests on top of the warm water, the less dense warm water rises to the top bottle and the cold water sinks. The movement of water is clearly seen as the yellow and blue food coloring mix, creating a liquid. Water is a great substance for soaking up heat. The thin balloon allows the heat to pass through very quickly and warm the water. As the water closest to the flame heats up, it begins to rise and cooler water replaces it at the bottom of the balloon. This cooler water then soaks up more heat and the process repeats itself. In fact, the exchange of water happens so often that it keeps the balloon from ever popping. Just like we use salt on icy roads in the winter, salt mixed with ice in this case also causes the ice to melt. When salt comes into contact with the ice, the freezing point of the ice is lowered. In the water thermometer experiment, we have created a sealed environment around the water. That is to say, there is nowhere for the water to go as it expands because the rest of the space is filled with air. The straw gives the expanding water an area where it can expand. In comparison, the opposite happens when water is cooled. The molecular bond that holds the H2O molecules together contracts, bringing the molecules closer together.